Hi guys, my name is Trevor Sullivan, a trainer with CBT Nuggets, and welcome to another CBT Nuggets skill covering the overarching topic of Kubernetes. Now, in this particular skill, we are going to be focusing our time and effort on understanding the storage subsystem inside of Kubernetes. Now, you might be wondering, hey Trevor, why do I need to understand how storage works in Kubernetes? And that's a totally valid question. The reason that it's important to understand storage in Kubernetes is because some applications are stateful. And a stateful application essentially means that the application is going to be storing some kind of data on a disk or perhaps a file system somewhere in the cloud or perhaps on a bare metal system. Now, not all applications are going to be stateful. Some stateless applications, such as a web service that maybe just serves up some static files, or maybe it just serves up some dynamic content that's coming from an external database or some other kind of data store, some applications are not going to be stateful, and instead, all of the files that that particular stateless application needs in order to operate properly are actually going to be wrapped up inside of the container images file system. So in those particular cases, you don't necessarily need to know about storage. However, some applications are going to be stateful. So what are some examples of a stateful application? Well, you might have something like a Postgres SQL database or a MySQL database, or perhaps a cache that needs to be repopulated anytime that cache service starts up from a persistent storage mechanism such as a block device. So what we're going to be doing is diving into the different concepts around storage in Kubernetes and understanding how these volumes and persistent volume claims and things like that are going to work. So we're going to start by kind of drilling into the documentation here for Kubernetes, which is really the best place to learn about how storage works inside of Kubernetes. So if you head over to the Kubernetes homepage right here at kubernetes.io and then drill into the documentation section here, there is some excellent conceptual documentation that we're going to be drilling into, specifically targeting the storage subsystem in Kubernetes. So if we drill into concepts right here, you'll see there's a whole bunch of kind of subtopics here that cover things like cluster architecture, which we cover in a separate video training skill, how to spin up containers, which is also a separate skill using kubectl to spin up containers and pods and things like that. And then if we drill down just a little bit further here, we've got storage. And so this is where we're going to be spending most of our time. Now, once you drill into the storage subtopic, you're going to be presented with a series of subtopics within just the storage context, and these are some of the different concepts that we're going to be drilling into in this particular video training skill. So as you can see, we start out with just volumes here, and then we have something known as persistent volumes. And there's a subtle difference there, but we're going to explain that in a little bit here. We also have a relatively new ability to take snapshots of volumes as well and actually manage those as Kubernetes resources as well. And then for the container storage interface, there's actually a feature that allows you to clone volumes as well. So if you have a snapshot of a volume and you'd like to clone that into a new volume, you can certainly do that, or clone from volume to volume rather. There's also a concept for provisioning persistent volumes in Kubernetes known as storage classes, and that allows you to essentially define a class of storage. So think of like AWS, for example, where you've got different tiers of storage performance. You've got throughput, optimized hard drive magnetic storage, you've got cold magnetic storage, you've got GP2 and GP3 SSD general purpose storage, as well as the higher tier like IO1, and I believe they even have IO2 as well for provisioned IOPS, where you need to pre-provision a particular number of IOPS. So what an administrator of a Kubernetes cluster can essentially do is pre-provision these different storage classes that point to different performance tiers, provision those as a resource in Kubernetes called a storage class, and then make that available to application deployers or developers and DevOps teams so that they can actually deploy persistent volumes using those different storage classes. So we're going to start with just kind of the basics here, looking into volumes and how those work. Then we'll drill into things like persistent volumes. There's also a more advanced concept within persistent volumes where you can actually statically or dynamically provision a persistent volume using something known as a persistent volume claim. And then you can also specify a storage class that you'd like to use for that particular persistent volume when you're actually deploying that out. So there's a bunch of different concepts that we're going to be drilling into here, but we're going to just start out with kind of the basics, which are volumes. Now, before we get too far ahead of ourselves, we're going to drill into these subtopics in future videos here, but I did want to mention that as prerequisite knowledge for this particular skill, I would strongly recommend that you understand Kubernetes basics and that you understand how the kubectl command line utility works. And we actually have a couple of skills that cover some of these topics. We've got kind of an introduction to Kubernetes skill. So if you just come up to our search box here on our website, or if you're on our mobile app, just go ahead and search for Kubernetes and then navigate over to the skills tab here. You'll have introduction to Kubernetes that just really builds on the foundational concepts of Kubernetes. And then we've also got another skill that talks about how to deploy and manage containers, or pods rather, in Kubernetes using the kubectl command line utility as well. And it's really important that you kind of get familiar with how to use kubectl in order to manage different types of resources on Kubernetes, because we're going to be using that extensively in order to manage storage and kind of explore how storage volumes work as well. Now, we also do have another upcoming skill as well that's going to talk about how to deploy Kubernetes clusters using the EKS-CTL command line utility. So if you do a search for EKS-CTL out on Google, this is actually just an open source utility that's going to allow you to deploy a Kubernetes cluster using the managed Amazon EKS service. So we're going to actually presume that you already know how this utility works and that you've deployed a cluster using EKS-CTL as well. So once you've got, EKS-CTL spinning up a cluster inside of your AWS environment, and you've got kubectl installed locally, make sure that that kubectl binary is connected to your Kubernetes cluster. That should be basically where we are starting off from. And just to kind of show you over here inside of my AWS account, if we navigate over to the EKS service in the AWS Management Console here, drill down into clusters here. I actually have a cluster that I've already pre-provisioned here just called storage testing. And just for reference purposes, I am going to be using Kubernetes version 1.20, which is currently the latest supported version by the Amazon EKS service. So I actually originally provisioned this using EKS-CTL as a 1.19 cluster, and then I actually upgraded it up to 1.20. However, I believe you can actually just use EKS-CTL to create a new cluster directly at version 1.20 as well, and that'll save you that extra upgrade time. And then I do currently have a couple of compute nodes as a part of a node group that I have provisioned into this cluster. So I've got two different T3 medium EC2 instances that are acting as my workers. And we can kind of verify that right over here by going over to our CloudFormation service. And you'll see that I've got two different CloudFormation stacks that were provisioned by EKS-CTL, of course, that handle the cluster itself. So here's EKS-CTL storage testing cluster, and then I also have my node group right here. Those are my worker nodes that are connected to my cluster. Now, just as another quick overview here over in EC2 as well, you'll see that I only have two EC2 instances in this particular region in my AWS account here, and these are the two nodes that are connected to the cluster. And I just wanted to point out which availability zones those are deployed in. So I've got one in US West 2B as well as one in US West 2D. And the reason that I'm taking note of these availability zones is because once we get into provisioning storage volumes or elastic block store volumes on AWS, those elastic block store volumes are actually going to need to exist in the same availability zone as the worker nodes in Kubernetes that they are ultimately going to get attached to. So as an example, if we later on created an EBS volume right down here under EBS in the EC2 console here, if we were to provision a volume in US West 2A, that would not be able to be attached to any nodes in my EKS cluster because I only have two nodes and none of them are running in the US West 2A availability zone. So that's why I wanted to just kind of point out what my infrastructure looks like here in the current state, just so that you guys understand what we're going to be building on top of going forward. So definitely make sure you get EKS-CTL spun up and make sure that you get that cluster deployed. If you'd like to add more nodes across additional availability zones, you're certainly welcome to do that. But in my particular test cluster here for storage testing, I just have the B and D availability zones available for my worker nodes. All right, so that's pretty much all there is to getting kind of the base environment set up. The other thing as well, I guess, that I would like to point out is that I've got my Windows terminal here. Of course, if you're using Mac OS or Linux, that's totally fine as well. Just use your terminal of choice. I just happen to be using PowerShell on Windows, but if you'd like to install PowerShell on Mac OS or Linux and follow along, that's certainly great as well. But the main thing that we want to do is make sure that we've got EKSCTL set up here to get different resources. We're not really going to be using EKSCTL itself too much, but if we do use it to list our clusters, you can see I've got that storage testing cluster here. And then I also do have kubectl connected. If I do a kubectl version, then we should get back the client version. So I'm running kubectl 1.19, and then our cluster, as you can see, is 1.20 here. And then if I do kubectl, I believe it's cluster info. So cluster info right here. So we'll do kubectl and then cluster info. That'll just kind of show you some high level information about my cluster. You can see that it is running and it's healthy. And if I do a kubectl get pod or get namespace or something like that, we should be able to properly retrieve those resources using the kubectl utility. And the nice thing about using EKSCTL to provision your cluster is that it automatically configures your kubeconfig context to connect the kubectl utility over to your cluster using AWS IAM integrated authentication. So that's really easy to get your whole environment just set up with EKSCTL, and you should be good to go. So in any case, let's go ahead and jump into our next video where we'll deep dive into volumes and how to actually share a volume across multiple containers inside of a pod. I hope this has been informative for you, and I'd like to thank you for viewing.